Welcome, everybody. We're going to begin tonight's session by kind of doing a real quick little review of the concepts that we picked up in Tuesday's lecture, which is basically looking at relational operators, logical operators, uh, what Booleans are, how we put together if-else statements, and then one additional topic that wasn't part of the PowerPoint, which is what we call a switch case statement, which is an alternate form to do basically what I think of as a if, else, if kind of structure, especially a repeating one. So I'm going to start with, I'm just going to go right down this list here. And, maybe the way to do this is I'll just open up, this is like tabs, and then the tabs will be ready to go. And I'll just pop through the tabs. All right, so the first thing we're going to look at is operators. So remember, this is to kind of reinforce the concepts that we already know. An operator, for example, the equal sign is an operator, but remember that's not a mathematical one. The first one that they're demonstrating is a plus sign, right? So I think we know what this does, but basically that will add the two numbers together. So it works like it does in math. The equal sign, remember, is the assignment operator, meaning anything on the right side of the equal sign gets stored in the variable or object in the left on the left side of the equal sign. So you can do kind of a combination of those. The mathematical operators, so all the standard ones, plus, minus, multiply, divide. We have modulus. We haven't learned these yet, but there's an increment and a decrement, right? So you can do a plus plus or a minus minus, and those can be either postfix or prefix, I believe, in this language. So we'll see that later on. All right, so the ones that we're really more concerned with here, well, the assignment operator, I guess that one we just talked about, are really the comparison operators, what we call the relational operators. So for example, when I have like the greater than, less than or equal to, greater than or equal to, not equal to, or the double equal sign, those are the ones that we're kind of reviewing here. So remember, when you see the double equal sign, this, I always think of it in my brain as equivalent to that. And I say it differently on purpose so that my brain remembers that it's different than the regular equal sign, right? So this is just kind of a thing. Not equal is with the exclamation point. The exclamation point, as we saw last time, can be used exclusively when you want to negate something that's already a true or false. So if you're checking to see, like if you're checking a Boolean variable, right, you can put a not sign in front of it that negates whatever it is, whether it's true or false. It just flips it. Greater than, less than, those are standalone. And then we have the greater than or equal to, or less than or equal to, and they have to be expressed in this order. There can't be spaces in between the indicators. And there is this logical or that happens in the statement too. So it's got to be greater than or equal to. It can't be both, right? But it's a combo term. Only one of those has to be true for it to be true. Remember that about ors, right? So those are comparison operators. We also have what we call the logical operators, which are the ands, ors, and not, right? And so that's the standalone exclamation point with a logical and I'm zooming out on purpose so we can see these as like one statement, right? We'll have that double ampersand expressed, and what we're checking here is for true or false on this and true or false on that, right? Now, in order for this to return true as a concise statement, both sides or all the aspects have to be true, right? And this is a really important one. So this statement would have to be true, and this statement would have to be true, right? All right. The other one is the logical or. That's expressed with these two vertical lines, which are technically called pipes. They're the shift of the backslash key, usually right above your enter key on the keyboard. And these work differently. Only one of the conditions has to be true for it to register true. So if this one was true and this one was false, then it's true. or vice versa. Not just negates the whole thing. So no matter what your thing resolves to, it doesn't matter. And here you see a complex statement, we're saying the opposite. So if like this all resolved to true, and I put the exclamation point in front of it, I'm really saying false. If this all resolved to false, and I put that in front of it, it's flipping it. It's checking for true, right? Now, you might not think of a lot of reasons off the top of your head why to do that, but I will tell you there are times it's easier to write the code that way than to write a statement that has to change all the verbiage of something. Ultimately, we're looking at this concept, especially when we're making decisions, is we have to have yes, no answers, right? True, false, or on, off, right? Those are all kind of like the comparison of Booleans. Where does this come from? This comes from how electronics operate, basically. Electronics operate with either positive or negative voltages. Something is either on or off. Is the light on or off? There's only like two states, right? And that extends further. It goes like beyond the electronic aspect into the whole logic of how computers work with circuitry. Circuitry begets working with binary numbers. So when we start to build CPUs or RAM or circuit boards or any of that kind of stuff, right? All of it is based upon either, we look at it as positive or negative voltages, or an on state or an off state, right? And if you guys continue on to like a 4-year degree, right? And for all I know, some of you already have one, and you formally study computer science as a thing, computer science will often take you down to the root level of circuit level design where they talk about this stuff, right? So if you go on and you do that as a degree path, it's one of the things that you learn. One of the things that I learned when I took like and I forget if this was my master's program or I think it was my master's program, where we did computer architecture, and we looked at how do you build like an 8-bit CPU or a 16-bit CPU? What does that look like? What is what are the pathways that you have to make that a possibility? And so all of it kind of stems from that. But this whole concept of true false is really important. So you can declare Boolean variables and assign them true or false, right? However, you can also have Boolean expressions. So like when you have an expression like this, it's really, you're not assigning a value or doing any operations. You're just saying, hey, is X greater than Y? Right. And in answering that question, we can steer a result. Now, if you actually do this as a right line, this is kind of bizarre, right? Because if you do the comparison as a right line, it will actually return true to the screen because that's the result of this. So Boolean expressions are at the heart of decision making in programming. When you start to actually move into the statements that you create to make decisions, there's basically a few different approaches. And the first three we've learned about, we did not learn the shorthand approach, so we're going to learn that today. And then we're also going to throw in the switch case statement, which is part of this as well. So for example, if I'm doing all these comparisons, right, you use all the comparison operators, right? They show you how those read. And then, for example, we learned about an if statement. So an if statement is we check a condition, and if the condition is true, we execute a block of code. If there's no else or else if, that's it, we just move on, right? The next level of it is when we ask the else question. So we have a thing that we check, we run the code. If it's true, if it's not true, we execute the other code. So that's else. Then we have else if, that's where we're checking maybe one condition or multiple conditions, right? So we check one condition, then we check another condition, right? So if this one is false, it moves on to check this one. If we have a bunch of else ifs with conditions, we check each one in order. The only way the lower ones will ever hit is if the top ones are false, right? So like you got to think about how you structure them to make sure you get the right result. And think about that example we had with like the grades and how we could do it. We could start with an F and work our way down, or we could start with an A and work our way up, or whatever, the concept is. So else ifs are another way. There's also this shorthand approach, and this is what we call ternary. We will look at this in later lecture materials as well, but here's an example, right? First, let's look at the syntax of it. The point is, you check a condition, you put in a question mark. This implies the if, and if this condition is true, then we execute this code. Colon, that's the implied else. Otherwise, we do that. So it works really well in very simple situations. So for example, here's one where if I had a regular if statement, I said, okay, I'm setting an integer of time to 20. If time is less than 18, I'll put this. Otherwise, output that. Or you can write it as one real simple little statement here, and notice that they're taking it and they're storing it in a string and then outputting the string, but they're testing it. And then if true, we say good day, or we store that good day. Otherwise, we say good evening. And this could just be a console write line for all we're concerned, but this is called a ternary approach to writing an if statement. This works really well when you have one little simple, concise action that happens in the if or the else. And this is a really nice example of it. So this is the shorthand approach. All right. What if you're getting into a situation, though, where you're writing an if, else, if, and you got like all these conditions you're checking, like 50 of them, right? Well, when would you ever run into that? Well, how about if you were writing a website form, and that website form has a drop down for all the states, and then your person clicks on their state, and then you have code like if from Wisconsin, charge 5% tax. If from Texas, charge whatever. If from Arizona, charge 0% sales tax. And I learned that, interestingly, I traveled down there and discovered in Arizona, they don't have sales tax. And I'm like, this is great. I should buy a car, because I can save the sales tax on the car. It's a lot of money when you have to start thinking about that, right? All right. But the point is, when you have multiple scenarios to check, you can use what we call a switch case statement instead, and take a look at how this breaks down. We still have some sort of an expression here. However, the expression does not necessarily need to be true and false. This is different. We might just be passing the value of something in. So for example, if I was selecting something from a list, like I'm looking for WI for Wisconsin, what I'm passing in might just be a string. And then I just go through and I check, all right, does it match this case? So like, for example, if this was a number, I would just list a number. If it was a string, I would list the string inside of quotes. And it just checks each case. And then if the case hits, it executes the code block. At the end of the code block, there's a break statement, which pops you out of the structure. So this works really well if you have a lot of things to check, right? This is a really efficient structure. And, probably I'm going to say the key takeaways of this are whatever code you're putting in there, you got to remember to have a break statement, right? Because otherwise, if you don't break out, it might check one of the other cases. One of those might hit, right? So you got to be careful on how you do it. We can also throw in a default. So if none of the conditions hit, it'll just hit this, which is kind of like an else. So you can think of the cases as else if, right, where they're checking a condition, and you can think of default as the else. So otherwise, it's very, very much like working with if, else, if, right? So here's an example. So we have an integer we're setting to the number 4. We're not checking for true, false here. We're just sending in a value. And then we're checking for that value. Is it 1? Nope. Is it 2? Nope. Is it 3? Nope. Is it 4? Yes. So we're going to write line Thursday, and then we're breaking out of the structure. We're not checking the rest of the code, right? So if I went through here and somebody input the number 15, none of these scenarios would hit. And notice there's no default statement in this one, so it wouldn't do anything. It's kind of like writing sort of like a bunch of if statements without an else. So that works for that scenario too. So this is a really interesting approach. And once again, it tends to work really well when you have a lot of stuff that you need to check. Right. So we'll probably get lectured on this again. So I apologize for that piece, but I think that it's helpful to know this aspect as we kind of move forward, because I might use it in one of the solutions tonight. All right. So what I'd like to do next then is, since we've talked about these concepts, is let's dive into working on the module 2 lab to start with. All right, so I'm going to go ahead, got to get into the right module here though, and bring up that assignment description. I'll read through this, and then we'll launch our coding tools and try to create the solution. So the breakdown is this. It says you've been asked to create a program that converts units of volume in the kitchen. Ask the user to enter an amount in milliliters and then select the units they want to convert to. So for example, you might want to take, like if you read like a European recipe, they might say like 3 milliliters of, vanilla, or something like that, right? Vanilla extract. And then, well, what does that mean in teaspoons or tablespoons or cups or quarts, right? So output the converted amount and the new measurement, output the converted amount and the new unit of measurement, round the amount to 1 decimal place. So we'll have to do that little piece too. And here's a sample program run. So it says enter the amount in milliliters, 75, and then people will choose. So we're going to have to put text up on the screen so they can make a selection, right? And then based on that selection, we'll do the conversion they want. So for example, if it's if they choose cup, 75 milliliters is 0.3 cups. Now, here's a little bit of an issue. What are the conversion amounts for this, and what is correct? Okay, well, I don't know, because this is a problem right here. So what do we do? How do we figure out what the right amounts are to convert?
Google it.
Yeah, right on. Well, right. We have the world of information at our fingertips. But it always floors me, and you guys are, I think you guys are pretty intuitive about this. But sometimes I'll be in the classroom and I'll ask my students a question. I'll say, hey, how many cups are in a gallon? And they all just sit there. And I'm like, you guys are sitting in front of computers. Somebody please Google it, or somebody ask your phone, ask Siri, please, All right. So not to be goofy about this, but we could ask AI to do it or whatever. But I do have my phone sitting here, and sometimes it responds to me when I don't want it to, right? And then sometimes I get all these political text messages like I'm getting because the election's coming up, right? So I'm trying to delete all those. But I'm just going to do this. Hey, Google, how many milliliters are in a cup? Okay, not responding, of course. I'm going to invoke it. How many milliliters are in 1 cup? All right, so
4.9 something.
All right, so this is what Google is telling me, and I'm gonna just to have a place to type this. And you know what? I should just type it right into Visual Studio. Let's go ahead and build the lab project. All right, so I'm launching the IDE here. I'm going to go ahead, create the project. We're doing a console lab. All right, so this should become pretty routine for you guys now. We should name it what it is. So I'm going to call it Mod 2 Lab. All right, that's what I'm going to name it. I don't want it in my repos folder. I want it in my documents folder. We'll select this folder. We're going to go with the defaults here. And so what I'm going to basically do here to start with is in the form of comments, by the way. What Google told me was, of course, the result went away, but it was something like 236 point like something. I'm just going to round, it was like 588. Is that what you guys came up with? Yeah. So this is what Google said. So 236.588 milliliters equals 1 cup. Right. All right. How about the next conversion? What would it be? Hey, Google, how many milliliters are there in 1 tablespoon?
There are approximately 14.787 milliliters in 1 tablespoon.
All right, I'm going to turn up my volume on my phone here so maybe you guys can hear it. But it told me 14.787 milliliters in 1 tablespoon. Of course, we have 2 more conversions we have to figure out. So I may as well make a spot for them. And those are going to be 1 teaspoon and in 1 quart. All right, so now we just have to get the other pieces here. So how about, how many milliliters in a teaspoon?
There are approximately 4.929 milliliters in 1 teaspoon.
How many milliliters in a quart?
There are 946.353 milliliters in a quart.
Okay. And I should probably label it like this, right? But this is our baseline information. So we do have to start with a little bit of research. Now, I could be critical of this and say, you know what, that could be typed into the description, right? So you don't have to look it up. But the reality is when you do like programming work, often you have to go hunting for info, right? Where are you going to find it? You're just going to sit there and pretend, no, you look it up. I mean, let's just be real about it, right? We have all these tools available to us now to be able to do that. All right. Next thing that we have to think about, and this is how I approached it, by the way, is we're going to be prompting the user to enter an amount in milliliters and put it on the screen. So I'm just going to go ahead and I'm going to begin with a comment, actually. And so I'm going to kind of make a little space here for myself. And I'm going to be focusing first on, basically the user input. I'm going to prompt my user, and I'm just going to do a very simple console write. And I'm going to just prompt them. I'm going to say, enter the amount in milliliters that you want to convert. All right. So, okay, question. If I'm capturing an amount in milliliters, what is the best numeric data type to store it in to get the correct precision given the information that we already know? Because none of these numbers are round. It's not like, hey, there's 14 tablespoons or 14 milliliters in a tablespoon. None of it works out perfectly.
A double.
Okay, doubles are what I heard, right? Yeah, and I would agree with that, right? Because that's a good format for storing floating point numbers to get the precision that we need. So let's set up a double. All right, we're going to call this milliliters. This is what the user is adding for us. We're going to do a convert, right? And notice, thank you, Visual Studio. I typed like 3-4 letters and it told me the exact thing to type. Should I just go through the trouble of typing it all in because it teaches me how to be a better human being? And I'm going to say, heck no. It's like getting in a car with automatic transmission after you learned how to drive stick. You just put it in drive and go. right? So we're just going to take that because that is correct. All right, here's kind of a secondary thing now. I'm going to actually need to put up on the screen a little menu that kind of looks like this, right? So we're prompting the user, and then we're going to put this up on the screen exactly. And then a prompt that says choose your conversion type. And so I could look at this as like, all right, I need one blank right line, and then I need 4 more right lines, and then a console write because this one's a prompt, and then a read line for whatever they choose. All right, so here's where my brain goes. All right, they're making a choice. So I'm grabbing another piece of information, and I want to declare that as a variable, right? Here's what I'm going to do is I'm going to just come up to the very top of my program, and I'm going to create a string variable that's going to hold the choice the user makes, which currently is blank, but I'm initializing it with a blank value. It is underlining, right? All it's saying right now is you haven't used it yet. Hey, fair warning, you haven't used this, so why do you have it? That's what that warning is. All right. So now we're gonna put that menu up on the screen, right? So let's code that. All right. So I'm gonna start, I said, with a blank line. So I could do that like this. I could just say console write line, and then not put anything in there, and that will just give me a carriage return, basically. And then since I'm going to do a bunch of these, right, I have what I have 4 menu options, right? There's going to be a 1, 2, 3, 4. So I'm pasting in 4 more. And then I'm going to have a prompt, but that one's going to be a write. So I'm doing this. Okay. So now I'm going to go one at a time. That one's going to stay blank. And then in here, I'm going to basically list what's here, right? And in fact, I'm just letting you know you can copy paste it, by the way. In fact, if you want to look precisely the same, copy paste all that. I know this would be a little bit messy here, but if you feel weird about that, you can always like do this, you know, but I'm not going to. I'm going to paste it in here at the bottom, deal with the error messages, but then I have it right here, and then I'm just going to add in double quotes and a paste, right? I'm just trying to show you how to be practical about this and basically save a little bit of time. Not that you're not capable of typing this minuscule amount of text, but I'll tell you what, it's also a lot easier than flipping screens, right? That one I can delete. And then this will go in the prompt, which will be down here, once again, inside of double quotes. And then I'll leave an extra space there. So that's kind of my menu. All right, we got to talk about this here though. What if on the first question, because this will pop up on screen first, enter the amount of milliliters, and they type 0. Or they don't type anything. Yeah, that's kind of a problem. All right, so I can only do conversions. If you think about this, I can only convert this if they're typing in a positive number, right? So I'm actually not even going to put this up on the screen unless the milliliters are greater than 0. Thank you, Visual Studio, for reading my brain and executing the code for me. All right, so I'm putting all that stuff in there. Another real handy little trick is you can highlight the lines of code inside here, and you hit your tab key, and you can, so basically you can grab a whole block of code and then hit the tab key, and it all indents at the same time. There is also a formatting tool. I always forget where it is because I never really do it that way. But somewhere in here they have a format document or format selection, and it puts it into Microsoft's preferred layout with all the indents, curly brackets, all in the right place. So that's something you might want to choose to use. So you guys see where that is: edit, advanced, format document, or format selection. Pretty handy. Notice they also have shortcut keys that go with. So Control K, Control D, Control F, right? Right. So the menu only appears if the number is positive. What happens if it's 0 or they type nothing or a negative number? It just won't give them the menu. Yeah. Is that okay? Well, Anthony, you're shaking your head, but you know what? I don't know if it's okay or not. Like,
Right.
we'll have to run the program and we'll see what happens and then we'll adjust, right? Like if we feel like we need to add something to it, like another message or error message or whatever, that's kind of on us as the programmer to figure that out. All right. So we put all that in there, but we're not reading in. We need to do a read line, right? Where are we going to store it? Inside of choice. So choice is our variable that will receive the choice, right? So that's a read line. No conversion necessary, by the way, right? Why is there no conversion necessary? Because it's already a string. It stays a string, right? What are they? Go ahead, Teresa.
Is there a reason to use a string versus an integer in this case?
Yeah, well, interesting question, right? So, correct. I could have them type in the number of the choice, right? Convert that to a number and then check the number. That's totally doable. But if they're simply making a choice, when they type 1, 2, 3, or 4, it's coming in as a character, as a string, basically. I really don't need to convert it to check to see if it's the same, right? So if you chose to convert it to an integer and then check the integer to execute your code, that's fine. If you chose to leave it as a string, that's fine too. So no right or wrong answer. No right or wrong answer. Right? If it works, it works, and that I think that's an important takeaway as well. All right. So now we're going to get to the point where we have to do, we got our inputs, right? So we got the milliliter amount. Now we have the menu choice that they're converting to. Now we can do the actual processing that we have the input. So inputs, processing, output, right? That pattern persists. So now I have a question I'm going to ask, right? Which is, what did they type as their choice? And when do I check the choice? So like just as on a really rudimentary level, I could do something like if choice equals 1. And notice, because they put it in as a string, I'm checking it as a string, right? If you did the conversion to numbers, you would just type number, right? So that would be the only functional difference here. So I could do like code like this. So if the choice is 1, then what would I do? I would put in my curly brackets and I would probably do the conversion mathematically, right? Now I know what the conversion amounts are because look, I have them up here. How handy, right? They appeared from Google magically. And so, for example, if the choice is 1, they're converting to teaspoons. And so I would need a variable to hold that. So I would say something like, all right, well, I think a double would be appropriate because there's decimal places involved. That's the one thing, right? And then I'd probably name it something that matches teaspoon, like TSP, right? And, my wife taught me this little weird trick. Like when you're looking at recipes, and they only use the letter T and they say like 4T and it's lowercase, that's teaspoons. And if they say 4T and it's the uppercase T, that's tablespoons. I never knew that about recipes. And I bet you that's why a lot of people screw them up, by the way. Yeah. But I like doing the TSP thing because that way, at least I know it's complete and I'm not guessing. So what is the conversion that we're going to do here? The conversion is we're going to take whatever the milliliters were, right? And we're going to multiply, divide.
Divide.
We're going to divide by that number that we have out there, which is 4.929, right? And that'll give us that'll give us how many teaspoons. We are also asked to maybe round it. Remember that part of it? Vaguely, right? Vaguely. All right. Let's say we weren't rounding it. How would we put this up on the screen? Would I do a right line? I could do that. I could do my string interpolation if I can find the dollar sign. And I could say something to the effect of, for example, ml, milliliters. And you know what? I'm so tempted to just let it finish my things for me. So I want to put teaspoons in there eventually too. But I'm going to say ml. Right? So this is going to put in a number. And then I want to say, so that many milliliters, right, is this many teaspoons. And I got to spell it right, but teaspoons. All right. So this would basically get the information on the screen. Now, it wouldn't take much to figure out the rest of this, because really what we have to do now is write a bunch of other if statements with these other conversions and then put it into the right format. All right, so here's kind of the lift that we have to do next. This is a mechanical process of just getting that all typed in. If this one works, right, then all the others should work too. Right? So might be smart to just check the one and see what happens. So I'm going to propose that we run this right now and see if this logic even works. Right? We got to make sure we don't type in 0 or negative numbers for the milliliters or nothing. We also have to make sure that we choose 1 from the menu when it pops up. Right? So let's just run this right now. I'm going to do a Control S to save. I'm hitting the run button. Pull it up on the screen here. Let's get the console loading. All right, and I will pull it off to the side so you can see it. Enter the amount in milliliters. So I'm going to say, I don't know, 25. Right. Press enter. Now it's giving me the menu. Not too bad so far, I think. Right. Choose your conversion type. I'm going to type 1 because that's the only menu item that's going to work. And there it is. 25 milliliters is 5.07 blah, 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 teaspoons. So how many teaspoons am I putting
in? 5.
Yeah, I would go with 5. Maybe just a pinch more, right? But 5.07 is basically 5. Right. Okay, so a couple of questions here. If we do rounding, how do we round it, and to how many decimal places do we round it? This is really kind of a weird thought. How many decimal places do we round it?
2.
1.
Yeah, so we're getting all sorts of different answers. Okay, question here would be, with some things, will it make sense to round, and with other things, may it make sense not to round? Question. What do you think?
It would make sense not to round because they're being like measurements, and you can't really do. I don't know if you can, but probably with a scale you can if you want to get that granular.
Well, let's think about this a little bit, right? Like if I'm doing teaspoons, I mean, it's possible. Like I've seen recipes, for example, that will say, and I know this because I have like little measuring spoon sets at home where it's like a half teaspoon, quarter teaspoon, right? And that's about as far down as it goes. So I'd say that maybe 2 decimal points is relevant, but the flip side is maybe not at all, right? So gosh, you know, we can wrestle with this a lot. Um, but for example, what is the command that we would use to do the rounding? Now we learned this in kind of like the chapter one stuff. Do you guys remember this at all? Does somebody want to drop it in the chat if you remember? What would be the code I would use to round this output? Because this is what I would be rounding.
This is what I use. I can drop it in chat. I don't know if
Yeah.
this is the right answer.
Well, Teresa, this is a process of exploration. So you use this approach. This is what Teresa used. Right.
But my variable isn't gonna.
No, right. But I'm just looking at, you know, the math round command.
Yeah.
Right. So you're using a math function to do the rounding. You're rounding it to one decimal place before you're actually inserting it here, right? So in other words, you basically, let's just say, would replace, I'm just going to show you here, right? Like to make it fit our code, I'll use my variable name, and then I'll just take that statement and put it inside this spot. This is a valid way to do it if we're rounding to one decimal place. Okay, so maybe I'm just going to kind of be devil's advocate here. Maybe 2 decimal places is appropriate, because if I have little measurement spoons that break down into teaspoon, half teaspoon, quarter teaspoon, I might a 2 decimal place answer. You know, like if I got like 0.22, that's close enough to a quarter for me to go, okay, yeah, that's a quarter teaspoon.
That
Right.
makes sense.
All right. So let's run it again just with this addition. So let's just go ahead and do it. So enter the amount. What number did I type last time? I forgot. Anybody remember? I don't know, 25, I think, right? We're going to go to teaspoons. 5.07 teaspoons. Okay. I'd still go with 5 teaspoons. I think this is okay. This is workable. Did anybody use a different approach to do the rounding?
I used semicolon and one after the variable.
All right. Grayson, could I? All right. So you did put it in the chat. Thank you. So, and I was trying to see if anybody remembered this technique, and Grayson, thank you for doing it. But what you did is, instead of doing this approach, right? And you see, and actually, let's comment out this line. And I'm not saying one is better than the other, but there's differences in how they operate. What Grayson did is he put in colon n 1, and you were rounding to one decimal place again, right? Right. So I'll use the 2 again. I just want to show you that either one can work. Now, the difference with this approach, right, is that we are not altering the variable. That's the difference. We're altering the output of the variable, not the variable. This approach is altering the variable and storing it. See the difference, right? And okay, so if you're looking for approaches, now, if we were doing science, I would try not to change the variable.
Yeah.
We're doing a recipe, I don't think it matters so much. So either approach is okay. Let's run it again. Let's see if the results are the same. Right. Using the same values, we have the same answer. So pick the one you like better. There's no right or wrong answer here. Now, where I would intuitively go, you know, in my brain, and you know, take that for whatever it's worth, you know, and that's it. Like, once again, it's not right or wrong, is I would have went for the same approach that Grayson did, because I don't really see a reason to add another processing step. I mean, this kind of is, it's just bundled in. We're just changing the output. People just want to know how many teaspoons of baking powder to put in their cake mix. You know what I mean? So, all right. So I'll leave this as the approach that we do now. All right. Let's go ahead and write the other if statements and then ask the question, should these be exclusive if statements? So should I have a series of like if choice equals one with no else? And then a different one, if choice equals two with no else. Should I do that? Or is this a if else if situation? What do you guys think?
I did a bunch of ifs. I don't know if that's right.
Yeah, I did a lot of ifs too. If, else if.
Okay, so Anthony, I'm hearing two different things. Teresa, did you do exclusive if statements? So
Yeah.
did your next if statement look like this one exactly?
Yeah.
So in other words, you did basically this. You changed this to the number two.
Yes.
You changed this to what's the second option? Tablespoon. So TBL, maybe it was how you did it. And then you changed the number here to be this. This is my assumption, right? So this is kind of a process of exploration here, folks, because Teresa did the ifs separately. Anthony did it like this,
Yes.
right? Okay. And is one better than the other? And do they both work? This is a really weird question, right?
One is not better than the other because they both work.
Yeah. You already tried it?
Yeah.
Yeah, of course you did. You know what? I'm glad you did because that's really okay. Now it says there's build. Okay, I see. Yeah, right. So this has to be. I have to change my code here. Attention to detail, folks. Right. All right.
Yes.
And remember, we're working on simple programs, but even on simple programs, it is important. So I'm going to go ahead and run this as two exclusive if statements, and let's see what happens. I'm going to keep using the same amount, right? Just so we have a baseline. And this time, I'm going to choose 2. I have 1.69. Okay, it says teaspoons. Okay, so it should say, right. Once again, attention to detail. Tablespoons. All right. Let's run it again just to be on the safe side. 25 milliliters, 2 for tablespoons, 1.69 tablespoons, assuming that's the correct calculation. Run the program again. 25, choose 1 this time. It works. So this approach works. 2 exclusive if statements is absolutely fine. It's valid. It works. All right. Let's now add the else with no else at the end, just an else if. Checking the second condition. Save the code, run it again. We'll try both options. Option 1 is fine. Run it again. Option 2 is also fine. All right. So, which is correct? The answer is both. Yeah, absolutely. Both of them work because the code executes without a problem, right? So I'd say both of them are okay. And you could use either approach. I'm going to continue with else ifs, right? And so, for example, right, if I did else if choice is 3, I didn't do my conversions here, but let's just do it. And 2. And of course, there's a 4. I don't want to do else here though, right? I still want to check to make sure it's 4, right? And of course I truncated that number. 0.588 is the actual number. So apparently last time I taught this, we had a whole discussion about how relevant that is, right? Which does happen. And then for choice number 4, and I'm just dropping this in, I'm copy pasting and I'm tweaking. And that conversion is actually 3.53. Not 0.53. Okay, there we go. All right, so we have all the conversions in. All of them are rounding the display. Do I need to have an else for this?
Yes.
Why?
Because when I ran into my code, I saw that I got the error message saying like, hey, it's not running completely, and it outputted like a 0. So when I tried to enter with the else itself, I believe that it closes the loop, especially if you don't put like one of those values in.
Okay.
You can do like a console output to say a console write line that says nothing entered or one of the selections was not entered.
Okay.
That's how it
You
is
know,
by trial
I
and
just
error.
want to check you on how you said that though. Like, cause
Yeah.
you said closing the loop. We haven't learned about loops yet. So we don't technically have a loop, but we can solve some problems with loops once we do learn that. So I would agree with that. So I would say that we want to have an else in here and we don't have to put in choice 5. We just want a plain old else, right? And what we could say there is, remember, what are they being prompted for? To enter 1, 2, 3, or 4. Right? That's what they're being prompted for. So we just want to tell them that it's not the correct choice. So what I would do is something as really as simple as this. I would just say that was not a correct option. Program terminated. Now if we had a loop capability to go back, we would just say try again, right? But in this case, we're seeking we're sicking the terminator on them and ending the program, right? Because we don't have that in our tool bag quite yet, but we will, right? So we will have that capability. All right, can we run this again and see what happens? Sure. Let's see if we're okay. All right, so we're going with the same amount, and I'm going to check. Well, we know the first 2 work, right? We've already tested those. So let's try number 3. 25 milliliters is 0.011 cups. Okay, I think that's good. One more time. 25. This time we're converting to quarts. It's 0.03 quarts. Do we want more precision on the quarts? I don't know. I think we'll just leave it like that. 25 milliliters is not a lot of quarts. Is the bottom line. All right. So I think all 4 options are working. What we haven't tried is what happens if they put in something stupid like 5. Okay, that's cool. Right, that works. What if we're going to try this scenario? So they put in their 25, and what if they just press enter? Okay, that works too. All right, so a couple different ways you can approach this. The one thing that keeps coming in my head though is, what about if they fudge that first thing? Like the entering the milliliters. What if they don't like type in something there? We didn't deal with that scenario. They put in the wrong thing for the menu. Okay, we got that handled. right? So let's think about like solving that problem. So what happens if they don't type the right thing here? Okay, so we do have a scenario that we're just checking to make sure it's greater than 0. But what happens if they enter 0? This is where I'm kind of leading to. So I'm going to put in a 0. Is this the right error message? I guess is what I'm asking you guys.
Well, it wasn't a correct option because from the option list, it gave us 4 choices.
Yeah. So how is that even working?
It shouldn't be working.
It should. My question though is like I'm trying to get you to think a slightly higher level here. Is how is it that I typed in 0 here in this prompt, so it wasn't greater than 0, so it didn't even put the menu on the screen, right? What was the choice? 0 is not an option here, right? And so do we say not a correct option? We could also just switch language and say not correct entry. That would be another approach. All right. Okay, let's test one more thing.
I
What
guess
if,
because that else statement itself is reading any other option that's not of the listed options, correct?
correct. And let's try a negative number. Okay. I don't like the verbiage it's responding with, but it's not working. That much is true, or it's not doing anything wrong, I guess. But what if they also like did this? Okay, well, that's a problem. So they are, we are expecting, um, you know, a number.
Right, because it's
So
double.
yeah, so I would say that you want to tell your user that. Now, I'm looking at my solution from last time, and I think this is kind of interesting. What we did is we put, and this is my group from last year. We took all of the if statements here, and then I'll do the maneuver here, and you guys tell me if this is necessary or not. I'm going to use my tab key. I'm indenting everything one level. And then here, I'm going to write another if statement, and I'm going to say, and notice what Visual Studio is doing. If choice doesn't equal blank, so in other words, they don't type a blank, right? What choice, like, so what, we didn't test that. We didn't test to see if they type a blank at that prompt, did we? Right. So as long as they don't type a blank choice, we can respond to it. But what if they do type a blank choice? Then we put in an else, and then you might do, this is what we did last time. And this is the comment I included with it, by the way. I said this will show when the user doesn't type anything when shown the menu. Nothing was entered, program terminated. Okay, same ultimate message, you know. Is this a viable approach? All right, so let's give it a try. All right, so all right, the program had crashed, so I want to relaunch it here. So enter the amount in milliliters. Let's use a bigger amount this time. Let's use 250, right? And then we're just going to press nothing. Okay, what would we normally do in a program? We would loop and say, please enter a value, right? Something to that effect. There's a bunch of little tweaks I could make to this to make it more. Let's run it again. Let's try that bigger value. Let's try cups. let's try tablespoons. Tablespoons. But I would basically call this working. This is, I think, an adequate solution. And then what I would like to do, like, if you guys want to call this a complete program. So if for the screenshotters in the crowd, right? Because I get people that watch the videos and the screenshot the whole thing. This is the top part of the code, middle part of the code, bottom part of the code. All right. And we're going to call this a success. I think this is a good lab. However, okay, so here's the however. I want to show you a different approach because there's more than one way to do this. And I'm going to speculate that many of you might have done it completely differently. So I'm going to kind of do another solution for this, but I'm going to use a switch case statement to show you that that's applicable here. And I'm going to show you kind of like a different way to structure it, and why this might be a little bit more efficient, right? So here's how I'm going to accomplish this is I'm just going to go ahead and I could just do it here at the bottom, I suppose, right? No, actually, I'm just going to do a new program file. I'm going to save this. I'm going to close the solution. I'm just going to make a new console app. We'll call it mod 2 lab alternate version. Same folder, same settings. And I'm going to do this in a little bit of a hurried up fashion. So just to kind of show you the mindset here. Well, we have a bunch of things, right? So we still have all the same conversion amounts, but we're going to have a bunch of double variables. So I'm just going to declare them all at once, not assigning any values. I'm just declaring them. We also have to have a way for the user to make a selection. And we did it as a string before, but this time let's do it as an int, right? To show you both are valid, right? So if you decided to go the int approach for option, hey, perfect. Right? I called it choice before, this time I called it option. Then I'm going to do a prompt and a conversion. So here comes that. All right, so I just prompt to the milliliters, then convert, right? Convert it to a double. The variable's already declared. Then we're going to put our menu up on the screen. Here it is with one console write line, a little bit more efficient, right? But you know what I like about the other approach is you kind of see what it looks like before it hits the screen. This approach, you don't see it as much, but whatever. Right? But one line instead of 4. And you know what? I like having a blank line in between, so I might like do a slash n at the beginning also. Oops, n, not m. And then I might actually add another blank line here, except inside the quotes. Right. Then we move on to our prompt and the capture of the choice. There's the prompt. Converting to an int this time, right? Because we're actually capturing it as a number. Right. So really, this looks different, but we really did the same thing. We just did it slightly differently. You guys feel that? But less lines of code. Now, we were going to do this with a switch statement. So let's go ahead and do that. So I'm going to type in switch. This time we're checking the option. It's not a true false here. We're just feeding the value in, right? Putting in our curly brackets. And then we start listing our cases. So for example, because we're checking the case of it being a number, we're going to have case 1, right? And the code that comes with it. Well, the code, and I am copying here, right? So this is what we did last time. Notice rounding to 1 decimal place, whatever, doesn't really matter too much. There's case 1. Case 2, 3, and 4. And we will throw in a default on this, which is kind of like an else. And then we're going to just keep it super simple. And say something like invalid input. You are an idiot. No, I'm trying to be funny, but it's not really working too well. Invalid input, you want to say program terminated, whatever, that's fine. And so here is an alternate version, folks. So this is top part of the code, bottom part of the code with the switch statement. I'm going to go ahead and run it. And I'll leave the switch statement, active here so you guys can see it in the background. Let's try in our little amount, 25 teaspoons. Okay, it's rounding differently, but we can just do this. Notice that when you're doing that rounding, doesn't matter if you use a capital N or a lowercase n, either one works just fine. All right, saving, running again. And I don't like that the prompt is like right there, but all right, let's type in 25 again. We'll do quarts. All right, so you see how we get the same answers. And then of course we should probably test it to see if, like, what happens if, I don't know, -3 is typed. Oh, weird. Right, so our program is a little bit better in that it wouldn't allow a negative value. And of course, I made it fail even more. So let's try that again. 25. Okay, that's not what I meant to do. Blank. All right. So this version still has quirks. I think that we would still have to accommodate for bad entry. But in terms of actually doing the calculations and running the code that does the conversion, this could replace that if, else, if, or if, any of those work, right? So you see the kind of like all the different approaches there and how all of them operate. All right, what I'm going to do here is I am going to, we're going to go into a break because we've been going for a while here. All right, we're back from our break and we're now going to start working on the module 2 assignment. And I like to call this one, which restaurant, is kind of the thing. So let's read the scenario here. It says you're hosting a surprise birthday party for a friend and you want to hire a local restaurant to cater it. You sent out invitations to the attendees and asked them for their dietary restrictions. Write a program that helps you decide which restaurants you can order from. And here's a list of available restaurants and their dietary accommodations. Okay, so for example, we have this list, and these are all places that are kind of within the WCTC zone, right? Like all out in Waukesha County there. So we have Thunder Bay Grill, Marco's Pizza, Cafe Mana, India Kitchen, and Harvest Cafe, right? And then we have just basically a table of information here with columns that shows like, does this restaurant have vegetarian options? And you can see like they're marked yes and no. And then notice the correlation, yes and no is a lot like true and false, right? So, we ask these positive, negative questions. What about vegan choices? So do you have like options for vegans at these restaurants? And then do you have gluten-free choices? And once again, some restaurants have options and some don't, right? And so you have this complicated matrix here. It's not just a simple, hey, we're having steak or we're having salad or we're having, bread and butter or whatever it is, right? There's a matrix here of like possibilities. So for example, if all of your attendees said that they're vegetarian, vegan, and gluten-free, where are you eating? If all of them answered, well, that's pretty easy. You got 2 restaurants that accommodate all of that, right? So you see kind of like what the scenario is. So you got to figure out, what restaurant works, for whoever that person is. So no, people without a certain dietary restriction may still eat at restaurants that accommodate that restriction. So here's kind of the caveat, right? It's like, hey, normally I eat gluten, I eat dairy, and I eat meat. So I guess if you don't give me that, I can still eat. That's kind of the point of that. So in other words, if no guests report any restrictions, then all 5 restaurants would be acceptable to order from. Makes sense. All right. Here's a sample program run. Is anyone attending the party a vegetarian? Yes or no? Is anyone a vegan? Yes or no? Is anyone gluten-free? Yes or no? And notice how they're prompting and they're putting up the letters, right? So that we're expecting the user to basically type lowercase y's or lowercase n's, right? And then based on those choices, we're going to shuffle through this table or this matrix of possibilities and come up with whatever the right answer is. So remember, like the example here is vegetarian, vegan, and gluten-free. All 3 are yeses. Well, here it matches up, right? So that's why we have this as the output. All right, so let's get into Visual Studio and start coding. I'm going to go ahead and create a new project. This is going to be a console app. Let's name this module 2 assignment. And if you want to call it which restaurant or whatever, that's on you. That'll be enough for me. All right, I'm going to go ahead and click create. And I'm going to remove this pre-existing code here. As with the previous lab that we did, I am going to demonstrate 2 different ways to accomplish this. And I'm also going to have you make some considerations here because this is pretty normal that when people do this exercise that they forget about some of the possibilities, by the way, because the possibilities become a little bit more involved, is the way to say it. All right, so here comes the beginning, right? Why don't we just start with the prompts? Does that seem reasonable? Let's just get the prompts on the screen and capture them, right? All right, so here's how I did that. I just said, for example, I just copied the exact thing from the screen. Is anyone attending the party a vegetarian, right? And then I set up variables. And then I want to throw a couple things in here. The first thing I'm throwing in here, you guys remember the question mark thing? Remember the purpose of that? And most of you are probably gonna go, no, I don't remember.
Interpolation? Or
Nope. Good
no.
guess. Nope. This is being put there basically. What if the user doesn't type anything? If I didn't put this question mark in there, we would probably get errors in our code later because a question wasn't answered. So if somebody types a blank and we're expecting a value, it could create the program to crash. Putting the question mark there allows the value to be null or empty and not crash the program. Okay, so I'm just putting it in. The other thing that I'm doing is whatever they're typing in, I'm expecting a lowercase y or an n, but there is that cap locks key. Or worse yet, you have those people that are snarky and try to type the wrong thing on purpose, right? So if they type upper and lowercase by mistake, I'll convert it to lowercase for them. I could do it a different way. I could just capture it as is and convert it later, but why? Let's just do it now. So that's the first prompt. Then we'll do the second prompt. I'm trying to time these out so you guys have a chance to hurriedly copy paste or type, right? So there's the vegan one. So I'm just calling it veggie, vegan as my variables. And gluten free. That one I just abbreviated as GF. All right, so those are our prompts and the capturing of info. All right, I'm going to go back to the description here. Okay, so we have one more output line that we should put in, which is this one. It says you may order from the following restaurants, and I'm going to put a \n at the beginning to give me a blank line, and then it'll give me a list. And you know what? I'm going to do a \n at the end too, just to push the output down. All right. Now we need to start doing our problem solving, right? So, and normally, like, see, we're doing it backwards, right? We're doing the thing that I always complain about, which is like we went to Menards, we bought the 2x4s, the hammer and nails, and we're getting busy. But what we should have done first is made a blueprint for the house, right? And normally the way I would do this is I would either, this one's probably more of a flow chart one because we're given a table and the table is kind of visual. So in other words, I'm looking for people to type yes or no to these three questions and then take the results of what they type and match it up with this table. So in other words, if I take this first series of no's and I say, for example, well, maybe I should just type it. All right, I'll just type it. All right, so I'll just say if, set of parentheses, right? If veggie is equivalent to n, right? And vegan is equivalent to n. And notice the double ampersands too. This is the logical and. Gluten free is also equal to n, right? That kind of matches the top row, right? No, no, no. Correct? Yeah, right. So if all three of those are no's, where can a person eat?
Anywhere?
Okay, so somebody's saying
Thunder
anywhere.
Bakery. Thunder Bakery.
So is that the correct? So
So if it's no, they'll be able to eat anywhere, correct?
okay, so Anthony, you're thinking that now you're thinking correctly, and I like the way that you said that. That is correct, right? They can eat at any one of those 5 restaurants. It doesn't matter.
If they're not, they don't have a condition for any of those.
Right. If if we could ask the inverse question, right? Which is, are you okay with veggie, vegan, or gluten free? You would see, and this is where the logic part comes in. But the correct answer is you can eat at any of the restaurants. So you would list them all. I have some sort of syntax error up in that statement because it's underlining. Got to figure out why. Anybody else getting an underline on their code?
I'm still typing.
Me too.
Oh, I see it. Let's see if your eyes see it. Right there.
No
Single
double.
equal sign.
Oh,
Yeah. Oop. There you go.
What does that T do with the \T?
All right, this is one of those escape sequences like this is. This creates a new line. This is a tab stop.
Oh,
That's to get it to indent like this.
gotcha.
And I probably missed this, but going back to the two lower, I'm not understanding why that's needed behind the console read line.
Okay, basically what this step does is it takes whatever they type at the prompt
And puts it below.
and sets it to lowercase so that when I run my check, I'm only checking lowercase.
Gotcha. Okay.
Otherwise, I'd also have to say and capital N for each one of them. Right? Do you want to do that? I don't want to do that.
Is there a
Now,
two upper or no?
Well, you could convert to upper, right? If that's what you were checking.
Okay.
You just pick one or the other and go with it.
Got it.
It's kind of the solution, really. All right. Then we'll do here an else if. And you see it's already auto-suggesting, so I'm just going to accept it, but I am changing it, right? And I'll ask the next question. And what I'm using as a guide, by the way, if you guys are wondering, is I'm just looking at the table because this is a unique scenario. The next one is a unique scenario. So I'm going to choose that same scenario. So I'm going to say, well, actually, I'm going to copy this statement is really what I'm going to do, but I already have the veggie in there. So I'm going to add the vegan and the gluten-free, paste them in, but I'm going to change my things here. So I'm going to go from yes, no, yes, because that's what's in the second row of the table. That was my guide, right? So else if you have somebody you have some people that are veggie and some people are gluten-free. Okay, so now you need the ones that would check two yeses here, right? Well, this one works. This one works, right? So Harvest Cafe, India Kitchen, and Marco's Pizza. Or no. India Kitchen doesn't work. So it's Harvest Cafe, Cafe Mana, and Marco's Pizza are the ones that work. Am I right or am I wrong?
You're right.
You're very quick to agree with me when I'm incorrect.
Oh my God.
Totally
Whoops.
incorrect. This is once again, this is where this is like the puzzle part of this, folks, right? This is, and you know what? This kind of stuff can either drive you crazy or if you start thinking about it, really, this is the fun part of programming is really figuring out the true logic of this. Okay, so once again, you got somebody that replied yes to veggie, yes to gluten-free, and no to vegan.
So it'd be Mana and Harvest? Is that wrong?
Okay. So let's I mean because we have that table that we can come back and look at and I assume you guys are looking at it too. So we're agreeing that these two will work, right? Those two have choices.
Oh, I think I'm
It's the
looking at it
opposite.
backwards. Yeah,
Opposite.
what Anthony said.
All right. And so which ones don't work for vegetarians? Vegetarians. Okay, so we're not looking for vegan here. We're looking for veggie and gluten-free.
Right. So they can't go to Thunder Bay.
Yeah, that one's out. They can go to Marco's Pizza. They can go to Cafe Mana and Harvest Cafe. They can't go to India Kitchen though.
They can go.
Right. So gluten free.
So, and here's the thing that pops in my brain. So Marco's Pizza must have a gluten-free crust. Either that or they just give you a bunch of cheese and sauce in a box, right? They call it pizza soup. Right. All right. But you guys feel like what the challenge of this is, right? I mean, you gotta really think about it to make sure it's correct, right? Because the last thing you want is like, hey, this pizza's fine. And then they like keel over and die. You don't want this. Some people do have like the gluten-free people. Some people are really super allergic to gluten. You know, it's a thing, right? And I know a few people like that. My wife and I make a point of trying to eat gluten-free whenever we can because it's better for you, by the way.
So does my dad.
Yeah. But I'll still have a hunk of bread with butter on it. Hey, not that. All right, let's move to the next question here. All right, so we did no, 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 yes, no, yes. How about a yes, yes, yes? Let's do a yes, yes, yes. Right. And I'm just following table order once again. So here comes the else if statement. So I'm just going to drop that in. Here's else if. Yes, yes, yes. Curly brackets. Which restaurants meet all three criteria?
Cafe Mana and Harvest Cafe. I think.
Correct. Weird side question. Have you guys ever been to any of these restaurants?
Are they real restaurants?
Yes, these are all real restaurants.
I've seen
Yeah.
Marco Pizza, but I've never been to it.
Yeah. Marco's Pizza in the old days, they used to be on like I don't know what exact cross street it was like. I'm guessing like 53rd and Center or something weird like that. And we lived near there, and we would always walk up and order pizza and walk it home.
There used to be one on Griffin.
Yeah, I used to like it, but I didn't have very discerning tastes back then. So just kind of putting it out there. I haven't had one in like forever, so I don't know. But I have eaten at all these other places. All right, so these are the only ones that check all three boxes. All right. What's another scenario that we haven't checked yet?
Oh,
How about a yes, no, no? We haven't done that, right? Here's the else if for that. So veggie, yes, vegan, no, gluten-free, no. Curly brackets. Okay. Now we're back to the same questions again, right? So we can bring up the table, and maybe the easier way to do this, and I apologize that I didn't think of it before, is I can just do a snip of this. And then I can just look at it on the screen while we're looking at the code, because I do think that helps. All right, so now we can see all the info. Okay. So would it be appropriate then to say that the only restaurant that accommodates this is the India Kitchen, since the yes, no, no's match?
Yes.
Yeah,
No.
and no, I see Elliot shaking his head. And Elliot, what are you saying?
It'd be everything but Thunder Bay, since the only thing we're concerned about is vegetarian.
Ah,
okay.
yeah. So you guys are like seeing you're seeing this now, right? Yeah, he's totally right. So everything but Thunder Bay, kind of like that first one was kind of not what you thought it was, right? So with that in mind, do we have all the scenarios covered at this point? That is my question.
I don't think so.
Okay. So are there, okay, is it fair to say that it's smart to look at the table? And I'm sorry, I should just leave it like this, right, with the snipping tool, right? Is it smart to like try to match up our if else questions to match the table? We covered the yes, yes, yes. We covered the no, no, no. We covered the yes, no, yes, and the yes, no, no. All right. Are there any scenarios that we're forgetting about?
Did you say no, yes, yes?
What about yes, yes, no?
Right. That one's not really that. I mean, so yes, yes, no. And is that a thing? Right. I mean, we just keep going further and further down the rabbit hole on this. All right. So, really, if you want to code this correctly, you are going to get into this scenario where you have to code every possible. What was the one that you just said, Teresa? Yes, yes,
Yes.
no. All right. And then what meets that scenario? Yes, yes, no. This is how I see it. Right. You guys agree?
Yeah, yes.
Okay. Thank you. Thank you, somebody for agreeing.
It's taking a lot of time to process this.
Yeah, no, that's exactly what you should be doing, right? Like when we started this session here tonight, you guys were probably going, "Hey, we're just doing these two exercises. We're going to be out of here by like 7:30, right?" Because he's just going to copy paste the code. But now that you start to think about it, you're like, "Oh, wait a second." All right. So we did. Let's review. We did no, 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 yes, no, yes, 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 no, no, and we just did one that doesn't appear on the chart, but we figured out because we're smart that there's also a yes, yes, no. Is there another scenario that's still possible? There is. What about the converse of yes, yes, no? What about
Right.
no, no, yes? Right. So this is the one I'm talking about. All right. So this is the other scenario I'm thinking. How about no, no, yes? And then, okay, and I'm doing it again, and I didn't mean to, and I apologize. As I bounce the screens around like 50 million times. What fits this scenario? We're only looking for gluten free now, right? We don't care about vegan and vegetarian. So we have Marco's Pizza, Cafe Mana, and Harvest Cafe, right?
Yes.
Okay. Now, is your brain starting to hurt a little bit?
Okay.
Now, here's what we're doing, and if you guys aren't aware of this concept, in mathematics, when we look at a chart to figure out a bunch of true false possibilities, what we're really doing is like this is called permutations, is what it's called mathematically. So with a table of 3 yes no possibilities over 5 restaurant choices, how many permutations of yes no are there with 3 columns?
Repeat that again. Repeat that again.
You typing it into Chat GPT, Anthony?
No.
So you know
Oh.
what? It's totally okay that you do that. Actually, I'm totally fine with it because, real frankly, I would ask that question to Chat GPT. In fact, should I do it? You guys should say sure. Why not? Is what you should say. And all right. Chat GPT. So the answer is, see, there's a mathematical formula that this is like a mathematical law, basically, right? That since there are 3 columns, the total number of possible permutations of answers calculated is 2 to the 3rd power, or 8. How many have we coded?
1, 2, 3, 4, 5, 6.
6. Okay. So then the question becomes, what have we missed? All right. So here's the silly way to kind of like demonstrate this concept. And that, this is kind of cool. So I'm trying to show you guys that, even if you're a little, like, let's say, resistant to the whole AI thing, there are places and uses for it in a practical sense, right? So this table doesn't cover all of those, right? In fact, 2 of the listings in here are repeats. So we only have 4 of them shown here, but there's 8 possibilities. And then we compare that to our code. And what I really should do then is I should take this, right, and screenshot that. And now let's look at our code with that overlaid. And let's see if we can do this is really goofy, but I'm going to use the little highlighter here to kind of like check it off. Do we have a yes, yes, yes? Yes.
Yeah.
Okay. Right. Do we have a yes, yes, no?
Yes.
Yes. Do we have a yes, no, yes? Yes. Line 18. What about a yes, no, no?
Yes.
Yes. Do we have a no, yes, yes?
No.
Yes.
But we do.
No, we don't.
No.
Okay. So we need that one. How about a no, yes, no?
No. Yes. No. No.
We don't have that one either. How about a no, no, yes?
Yes.
That one we have. How about a no, no, no?
Yeah, we have that one.
We have that one. Okay. So how many more do we need to code?
You.
Okay, that's the thinking.
No,
Right.
because it's not in the list, right?
Okay, so this is a leap here. So Anthony's saying none because it's not on the list. I'm going to tell you, I think that's a mistake. Okay. Because just because one restaurant's thing might match up with one of the listings, we already showed a scenario where we had restaurants that didn't match up with the listing, but we still were able to select restaurants.
Yeah.
Okay, so I'm going to tell you that we only need to code one more because the other one can become the else. Or maybe we code both of them to cover all the scenarios. All right, let's just go ahead and code it. So the ones that we have to code that are left are these 2. So no, yes, yes. And I just want to make sure that we don't already have that. All right, so let's do that. curlies. So we got a no, yes, yes, and then I'm going to mark it here so I don't forget. No, yes, yes. So which ones give us vegan and gluten-free is really the answer or the question. All right. Not even sure what the question is anymore. Okay. So which ones give us vegan and gluten-free?
Cafe Mana and Harvest Cafe.
You got it. Okay. Then we have one more scenario, right? And that one is the no, yes, no. All right, so let's code that. No, yes, no. So I'm just like making sure here. No, yes, no. All right. And then we checked off everything. And then the only column that's required then is the center column. So what are the restaurants that tick that box?
Cafe Mana and Harvest Cafe.
Yeah. So those are right. And then let's throw in an else. Right. And here's my little snarky. Maybe you should just consider making something at home. Right. If you can't pick a restaurant, right? All right. Okay. So we covered a lot of scenarios, and we haven't even run this yet, have we? Right. But let's just assume that our logic is correct. I'm running it right now. Of course, we have the is anyone vegetarian? We'll say yes. Anyone vegan? We'll say no. Anyone gluten-free? We'll say yes. Right. And then supposedly this is the right response. Now, ideally, you would check all the scenarios. Right. We could call this a solution and call it a night. When you guys feel like my little pensiveness in there, that's like not maybe we're not thinking about this right. So Anthony, you're feeling where I'm going with this? Because you're giving me that.
Like this,
Yeah, I think you are kind of feeling where I'm going with it. So let me give you an alternate solution. And this one I'm not going to actually well, actually maybe it'd be worthwhile to code through it. I'm just looking at we got plenty of time. So I'm going to code it again. All right. So here comes I'm going to close this one. If you guys don't mind, you guys okay with this? Remember, it's going to be in the video, and you could always here. How about this? All right. Top part of the code, screen capture. middle part of the code, screen capture. Bottom part of the code, or most of the bottom part of the code, somewhere like that. Yep, that's the bottom part of the code. All right. I'm going to go ahead and close the solution. And once again, new project, console. We're going to call this mod 2 assignment alt. Right? And make an alternate version again. And with this one, I'm going to start off with a different approach. So this is kind of interesting, and I like showing alternates like this because it shows that people think in alternate ways, right? So here's where I start on this one. So instead of capturing veggie, vegan, and gluten-free as a string, I'm going to capture them as a character because I only want one character. So I don't need to use a string data type when a character data type is adequate. I am going to set up a string variable called restaurants that's going to basically serve as a way to capture the restaurant. Now I'm looking at my solution here, and I don't think that's going to be even used here. I'm looking at my code. Yeah, so that's not even going to be used. So I don't think we need that. I'm going to comment it out. So it just shows like the evolution of my code basically in the solutions. All right. We're going to do the same prompts. However, here's the however. We are capturing them and converting them to characters, right? To store in those things, just in case they happen to type more than one character. Technically, one character won't crash it, right? And we're assuming they're not going to make a mistake and type an uppercase letter. So we could do the two lower thing. I'm not going to do that. That's not really the main point here, right? I want to show you a different way to think of the logic, right? All right. Instead of a bunch of if else, ifs and all that, I'm going to start with this. If somebody selects no, 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 we can go to Thunder Bay Grill and get the steak, the potatoes, and a big basket of bread, all smothered with non-vegetables, tons of dairy, and breads and everything. Right? That's what that's saying. Right. And if somebody is vegan, we're going to say Marco's Pizza. Now, hold on a second. You guys are going, what about Cafe Mana and what's the other one? Harvest Cafe. Well, yeah, you're right. You know what? We'll just output those. You know what? Here's like where the logic takes you on this. If you look at the list carefully, Cafe Mana works for everything. I don't have to even ask. It's on the list.
Hmm.
Right? You guys feel what I'm saying here? Right?
Yeah.
The other scenario that we're not accommodating for is if somebody might be gluten-free and they're not gluten-free and they're not vegan, in which case the India Kitchen works. But either way, the Harvest Cafe works. And there's the solution. This is done.
I like that way.
I wanted to.
Now here's the test on this though, right? How do we confirm? So once again, let me go back to this little table here. I'll capture the table so we can have it for reference and overlay it over the code, right? And we can kind of just side by side them here. So if somebody says, no, 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 Thunder Bay Grill is good, Cafe Mana is good, and Harvest Cafe is good. Is that true?
Can you ask it again?
Yeah. So if somebody says any veggies, any vegetarians, no. Any vegans, no. Any gluten-free, no. Which restaurants work?
All of them?
That's what we came up with last time, right? So is our answer here incorrect? This is really a little bit of a brain bender more than you guys are giving it credit for.
No to veggie, no to vegan.
Because right, you're right. Last time we said that all the restaurants are good in that scenario. So is that true or not?
I'm not. It is. Because they're saying I'm not.
All right, but so here comes the logical leap that you guys are missing, right? Because you're thinking that I should list all the restaurants here.
Mhm.
But if I follow the table and look at my code, if somebody says no, 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 it will output Thunder Bay Grill. There's no else if here. See the difference?
Mhm.
Then it'll check, is vegan? No. All right, well, Marco's Pizza is good too. Cafe Mono works in every situation. And if somebody says no and no to vegan and gluten free, India Kitchen is okay, and the Harvest Cafe is okay. All of them will print on the screen.
I get how you do it. I get that part. I'm just conceptually trying to think.
Yeah, I know this is
I
it's
get how
weird,
you did.
right? So the way that we did it before, where we asked every possible permutation,
Right.
set up complex and statements to make sure every scenario was covered, will work. But which way, right? And so let me go back to our previous solution, and I have it as a cheat sheet over here, right? We were doing this, right? We're checking every scenario, writing all these lines of code. But what you start to pick up on after a while is that certain restaurants work in every situation. So our previous code did have flaws to it, by the way, right? Um, okay, so where did it have flaws? Well, I can show you, but this scenario is actually cleaner, answers all the questions, and is significantly less code. This is a really strong demonstration, folks. And that's why I like showing this, is because the tendency is to overthink the problem, right? And it's not like we wouldn't get to the right answer, but there are some flaws in our code. And let me see if I can pull up I'll do this in a separate tab here. Because I already altered my code from last time. And mod 2 assignment, and we'll pull this up on screen. I'm just going to put this in the other window. And I'm pulling this up in Notepad++, which is not really truly an IDE, right? And then let me minimize this window. All right. And then if you can, overlay the table at the same time. This gets a little challenging when you only have one screen. You're trying to look at all this stuff at the same time. All right. So with a no, 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 we already confirmed all the restaurants. So we assume all these answers are correct, right?
Right.
And we already proved that this approach would also print the same restaurants. It's just using a different logic structure. Then we have the yes, no, yes. All right. In the yes, no, yes, Thunder Bay Grill is not going to happen, right? Marco's Pizza happens because vegan is no. Vegan is no, Marco's Pizza happens. Cafe Mana, Harvest Cafe always happens. So that's good. What about yes, yes, yes? Well, right off the bat, that eliminates anything that's got no in the table, anything that's got red in the table. So it's only those two. So that one's right. What about yes, no, no? Right? So vegan and gluten free, India Kitchen is included.
So it's sort of like once you check one, you just this process of elimination a bit.
It really is, right? And so what
Once you check some boxes, this one checks that to simplify it a bit.
Yeah, I mean, but the reality is both of them work.
Right.
One is a whole lot less efficient than the other. And this is one of the challenges of programming, folks, is because when we write code from scratch, using the Menard scenario again, right? We just got busy. We bought the 2x4s and we got busy. We didn't think about what we were doing. Whereas if you sat down and you really planned it out, we were looking at it as checking the boxes and then figuring it out. But what the no's are were a clue to streamline the code. We didn't need to do else ifs or anything like that. We just had to think in the converse because we were thinking more like which restaurants are yeses, not which restaurants are no's. You see the difference?
Mhm.
Right. So we were just thinking in the negative. However, we saw the longer, complicated way to do it that does work. And then our eyes were opened because we were able to basically do the same thing with, I mean, it's not 5 lines of code, but 7 lines of code, whatever, 8 lines of code. Right. All right.
I see what you're just pretty much mimicking the table itself.
Precisely.
Yeah. I got it.
So the table really was a clue,
Mm-hmm.
right? We just, in our code here, well, the one that I just took off screen, we were worried about accommodating for the yeses, right? The one that what we actually had to worry about was the no's.
Yeah.
It's like, all right, well, if they say, no's, which restaurants can we exclude is really kind of what it comes down to. So it's just a matter of understanding the problem in that capacity. But the fact that we were able to look at 2 different ways to do it, both of them valid, and then understand why one approach is better than the other, right? That comes with the experience of programming, real frankly. And the other flip side to that is even experienced programmers might do exactly what we did before they figure out how to fix it. And then what a lot of people are doing these days is they are dropping their code into like Chat GPT and going, hey, how do I make this code more efficient? And chances are Chat GPT would give you that answer like we have here. This is more efficient. All right. I'm going to end this video here, but I thought that was a really good lesson in how to work with if statements, conditional logic, and complicated ands and ors, and to look at a problem and break it down and come up with the right answers.